In the spring of 2022, a pair of bald eagles built a nest on a wooden utility pole standing in the middle of an industrial complex on the outskirts of Bethlehem, Pennsylvania. Not near the complex, not on the forested ridge above it. On the pole itself, inside the facility's perimeter fence, surrounded by warehouses, loading docks, heavy equipment, and the constant movement of diesel trucks operating on a 6-days-a-week schedule. The nest was substantial. Bald eagle nests, which the birds add to year after year, can reach weights of several hundred kilograms, and this one was already well established when facility workers noticed that the pair had returned for what appeared to be at least a second breeding season. The eagles were not troubled by the trucks. They were not troubled by the noise, the diesel exhaust, the artificial lighting that kept the yard illuminated through the night, or the human workers who moved beneath the pole at distances that would have been unthinkable in any description of bald eagle habitat written before roughly 2010. They incubated their eggs. They raised their chicks. They hunted in a retention pond inside the facility fence and along a stretch of the Lehigh River visible from the nest. They did what bald eagles do. They did it in a place that bald eagles are not supposed to be. The Pennsylvania nest is not an isolated anomaly. It is a data point in a pattern that has been emerging with increasing clarity across the eastern United States and into parts of the Midwest over the past 15 years, and that biologists who study the species are describing with a mixture of scientific excitement, genuine puzzlement, and a growing recognition that the categories they have used to understand bald eagle ecology may need to be revised more substantially than anyone anticipated. Bald eagles are nesting in places that contradict the behavioral and habitat templates derived from decades of careful study of the species during and after its recovery from near extinction. They are nesting closer to humans, closer to industrial activity, closer to urban cores, and in habitat types that were not represented in the data from which the species' ecological requirements were originally described. And they are doing it successfully. The chicks are hatching, the fledglings are surviving, the pairs are returning season after season to sites that the prior literature would have assessed as unsuitable with a high degree of confidence. The scale of what is happening requires context, because the bald eagle's current situation is inseparable from one of the most remarkable conservation recoveries in the history of North American wildlife management. In 1963, the bald eagle population in the contiguous United States had fallen to 417 known nesting pairs. The collapse was driven by a set of converging pressures that are now well documented. DDT, the pesticide that entered aquatic food chains and accumulated in fish-eating birds at concentrations that caused eggshell thinning severe enough to prevent successful incubation, was the primary mechanism. Direct shooting, habitat destruction along major waterways, and disturbance of nesting sites by human activity contributed. By the mid-20th century, the bald eagle had essentially disappeared from most of its historical range east of the Mississippi, and existed in the lower 48 states primarily in Florida, the upper Midwest around the Great Lakes, and the Pacific Northwest. The species that had been selected as the national symbol of the United States in 1782 was 180 years later functionally absent from most of the country it was supposed to represent. The recovery that followed DDT's banning in 1972 and the passage of a suite of federal protections is one of the cases that conservation biologists return to repeatedly when making the argument that intervention works. The bald eagle was listed under the precursor to the Endangered Species Act in 1967 and under the Act itself when it was strengthened in 1973. A captive breeding and reintroduction program combined with the gradual recovery of prey populations as DDT cleared from aquatic systems produced steady population growth through the 1970s and 1980s. By 1995, the species had recovered sufficiently to be downlisted from endangered to threatened. In 2007, it was removed from the list entirely. The 2024 population estimate for bald eagles in the lower 48 states stands at over 300,000 individuals, including more than 71,000 nesting pairs. That is an increase from 417 pairs to over 71,000 in approximately 60 years. It is not a recovery. It is a transformation. Transformations of this scale produce ecological consequences that are not always predictable from the original template of the species' behavior. When a population of 417 pairs exists at the outer edge of extinction, it is concentrated in the habitat patches that are most suitable, most productive, and most buffered from disturbance. The individuals that survive and breed in those conditions are self-selected for the ability to exploit the highest quality available habitat. Their behavior, their nest site selection, their tolerance thresholds, their habitat associations, become the data from which the species' ecological requirements are described. Those descriptions are accurate for a population in extremis. They are not necessarily accurate for a population that has saturated its highest quality habitat and is expanding into everything else. The bald eagle of the recovery literature, the bird that requires large, old-growth trees within a specific distance of undisturbed water bodies, that maintains large buffer zones around active nests, that abandons sites in response to human disturbance at distances measured in hundreds of meters, was not a description of bald eagle ecology in its fullest expression. It was a description of bald eagle ecology as practiced by the subset of the population that survived a near-extinction event in the most forgiving habitat available. The bird that is now nesting in industrial complexes in Pennsylvania and on apartment building ledges in New York City and in retention pond margins in suburban New Jersey is revealing what bald eagle ecology looks like when the population is no longer compressed into its best remaining habitat, but is instead expanding into everything its behavioral flexibility can accommodate. The nest site selection data from the past decade is where the departure from prior templates becomes most concrete and most scientifically challenging to interpret. Traditional bald eagle nest site descriptions, drawn from studies conducted primarily in the 1970s through the 1990s, emphasize a set of consistent features: large, dominant trees, typically greater than 60 centimeters in trunk diameter, capable of supporting the cumulative weight of a nest that may grow for decades. Proximity to productive water bodies, typically within 1 to 2 kilometers of a lake, river, reservoir, or estuarine system. A buffer zone of relatively undisturbed natural habitat surrounding the nest site, typically described as requiring minimally disturbed forest within 150 to 300 meters of the nest tree. Distance from active human infrastructure proportional to the level of disturbance that infrastructure generates, with high disturbance industrial and commercial uses historically associated with nest abandonment or failure. These were not arbitrary standards. They were derived from the outcomes of hundreds of nesting attempts and reflected the genuine relationship between habitat characteristics and nesting success during the period of observation. The current data is doing something surprising to those standards. Nesting success rates at non-traditional sites, sites that violate one or more of the criteria described above, are not substantially lower than at traditional sites in the regions where the comparison can be made. Eagles nesting on utility poles, cell towers, channel markers, and artificial nest platforms in industrial or semi-urban settings are fledging chicks at rates that field biologists are describing as unexpectedly high. In a 2021 analysis of bald eagle nest site characteristics and productivity across Maryland and Virginia, researchers found that nests in what they classified as disturbed or semi-urban settings produced fledgling rates statistically indistinguishable from nests in forested riparian habitat meeting traditional suitability criterions. The finding did not make headlines. It appeared in a regional ornithological journal and was noted by specialists without generating the kind of broader reconsideration of bald eagle habitat requirements that its implications arguably warranted. The utility pole nesting phenomenon deserves particular attention because it is both the most visually dramatic expression of the trend and the one that most directly challenges the prior understanding. Bald eagles have been documented nesting on utility poles in at least 22 states as of 2023. The behavior is not new. It has been recorded occasionally for decades. What is new is the rate at which it is being reported, which has accelerated substantially since approximately 2015, and the geographic range of the behavior, which now extends well beyond the states where it was first documented in the Pacific Northwest and Alaska. Eagles nesting on utility poles in densely suburban areas of New Jersey, Connecticut, and Virginia are not expressing a behavior confined to the vast, sparsely populated landscapes of the far north, where utility poles are sometimes the only large elevated structures available. They are expressing a behavioral flexibility in the context of a densely human-occupied landscape that prior models did not predict. The structural explanation for why a bald eagle would choose a utility pole over a mature tree when mature trees are available in the vicinity involves several factors that the birds appear to be responding to, though the relative weight of each is difficult to disentangle from observational data alone. Utility poles provide a height and exposure that dominant trees in fragmented suburban landscapes often cannot match. A mature tree in a suburban woodlot may be tall, but may lack the unobstructed sightlines in multiple directions that a dominant forest tree would provide. A utility pole on the edge of an open area provides unobstructed views across a wide arc and thermal and wind conditions favorable to the large-winged, soaring flight style of a bird that spends much of its time aloft. The structural stability of a utility pole, engineered to carry substantial static loads, may also function as a more reliable nest substrate than a tree that is subject to storm damage, disease, and the progressive structural deterioration that affects even the largest forest trees over decades. A bald eagle pair that has invested years of accumulated material in a large and successful nest has a strong incentive to place it on the most structurally dependable platform available. In a landscape where utility poles are more consistently present than large dominant trees, the bird's choices may reflect a rational optimization within the options the landscape offers. This explanation is partially satisfying and leaves something important unaddressed. The tolerance for human disturbance that accompanies the non-traditional nest site choices is not fully explained by structural optimization. An eagle choosing a utility pole inside an industrial facility is not simply selecting the best available nest substrate. It is demonstrating a tolerance for the human activity associated with that substrate that its ecological predecessors did not demonstrate. The disturbance buffer requirements that drove nest site assessment for decades were derived from behavioral responses, specific distance thresholds at which bald eagles flushed from nests, interrupted incubation, or abandoned nest attempts in response to human approach. The individuals nesting in non-traditional sites today appear to have disturbance thresholds that are substantially higher than those documented in the recovery-era literature. Whether this represents individual behavioral variation within the population, a generational shift in learned behavior, or a genuine evolutionary change in disturbance tolerance is a question that current research has not resolved. The learned behavior hypothesis is the one that most ornithologists find most plausible as an initial framework, and it is worth exploring in some depth because it connects to a broader set of questions about behavioral inheritance in long-lived species. Bald eagles live for 20 to 30 years in the wild. They begin breeding at 4 to 5 years of age. A pair that establishes a successful nest site will return to that site for years or decades, provided the site continues to be productive. The young they produce at that site grow up in its specific context, with its specific disturbance profile. A chick raised in a nest inside an industrial facility is habituated to industrial disturbance from the earliest stages of its neurological development. When it reaches breeding age and begins selecting a nest site, Its assessment of what constitutes acceptable disturbance is calibrated by its developmental experience rather than by an innate template. If it selects a similarly disturbed site, which the habituation process would predict it might, and if its offspring inherit the same early life habituation, a transgenerational ratchet effect is possible, in which successively bolder site selection becomes progressively normalized across breeding generations, in a population that began with a few unusually tolerant pioneers. This mechanism is speculative in its details, but well supported in principle by the literature on behavioral flexibility and individual learning in long-lived birds. It does not require genetic change. It requires only that a small number of behaviorally tolerant individuals succeed in non-traditional sites during the initial expansion phase, that their offspring develop calibrated disturbance tolerances based on their early environment, and that those offspring select similar sites with similar success rates. Over the 20 to 30-year period that constitutes a generation in this species, the effect could produce measurable changes in the population-wide distribution of nest site characteristics without any change in the underlying genetic basis of the behavior. The rapidity with which the pattern has emerged in the bald eagle record over the past decade is broadly consistent with this learned behavioral mechanism, though the pace of change is fast enough that some researchers are not willing to dismiss a genetic contribution to the shift without more data. The urban and peri-urban nesting records deserve their own sustained examination because they represent the most dramatic geographic departure from the historical template. Bald eagles nesting in the urban cores of American cities were essentially undocumented before the early 2000s. They are now documented in or immediately adjacent to the urban cores of Philadelphia, Washington, D.C., Baltimore, Richmond, and numerous smaller cities across the Mid-Atlantic region. The Washington, D.C. record is particularly striking because it is well documented, long-running, and occurs in one of the most densely observed urban wildlife environments in the country. The nesting pair that has occupied a site along the Anacostia River in the District of Columbia has been monitored for over a decade by wildlife officials and a dedicated community of volunteer observers. The nest is within sight of major roadways, under regular air traffic from Reagan National Airport, and subject to the full suite of urban disturbances that the prior literature would have assessed as incompatible with successful bald eagle breeding. The pair has raised chicks successfully in multiple seasons. They have become, in a modest way, local celebrities, with a social media following and regular coverage in regional publications. What the DC pair represents scientifically is a demonstration that the relationship between urban disturbance and bald eagle breeding failure is not as fixed as the prior literature suggested. The pair is not succeeding despite the urban environment in some precarious, contingent way. It is succeeding in the urban environment, using resources that the urban environment provides, specifically the fish of the Anacostia and Potomac rivers, whose populations have recovered substantially as water quality in the Chesapeake Bay watershed has improved, and the thermal and structural resources of the urban built environment itself. The urban heat island effect that makes cities warmer than surrounding rural areas extends to thermal column formation that large soaring birds can exploit for energy-efficient flight. The elevated structures of the urban built environment provide nest site options and hunting perches with sightlines that mature forest often cannot match in a highly fragmented landscape. The relative absence of certain predation risks in urban environments, specifically the great horned owl, which is the primary predator of bald eagle eggs and nestlings in rural settings, and which is present at lower densities in dense urban cores, may also contribute to the unexpectedly high productivity of urban nest sites. The food resource dimension of the urban and suburban nesting expansion is worth dwelling on because it connects the bald eagle story to a broader ecological transformation of the eastern United States that has been underway for decades and is still not fully appreciated in its scope. The recovery of fish populations in major eastern rivers and estuaries, driven by the Clean Water Act of 1972 and the subsequent decades of water quality improvement it produced, has been as consequential for fish-eating wildlife as DDT's removal was for raptor reproduction. The Potomac, the Susquehanna, the Delaware, the Connecticut, and dozens of their tributaries now support fish populations that were functionally absent for decades during the worst period of industrial and municipal pollution. The Chesapeake Bay, which sits at the center of the bald eagle's mid-Atlantic population, has undergone measurable water quality improvements that have translated into recoveries of menhaden, perch, bass, and other species that bald eagles depend on. An eagle, nesting in an urban setting in Washington or Baltimore or Philadelphia, is not nesting in a food desert. It is nesting near the best fishing in the region, fishing that exists precisely because the rivers running through those cities are dramatically cleaner than they were 50 years ago. The urban nest site makes ecological sense in a way it did not and could not have a half-century ago, because the ecological context of the urban waterfront has fundamentally changed. The Great Lakes region presents a parallel and independently instructive version of the same broad pattern. Bald eagle nesting in the Great Lakes Basin has expanded dramatically since the recovery began, and the expansion has included a progressive movement toward urban and suburban shoreline habitats that were historically avoided. Chicago, a metropolitan area of 9.5 million people surrounding the southern tip of Lake Michigan, now has documented bald eagle nesting activity within the city limits and in the immediate suburban ring. Milwaukee, Cleveland, Detroit, and Buffalo all have eagle activity in their immediate urban or suburban waterfront areas at levels that were not present 20 years ago. The Great Lakes fish populations that support this activity, including lake trout, whitefish, yellow perch, and the invasive but nutritionally abundant alewife and round goby, have their own complicated recovery histories. But the net result for bald eagles is a food resource of enormous scale distributed along shorelines that are increasingly occupied by nesting birds. The substrate flexibility being documented in the Great Lakes and Mid-Atlantic regions extends beyond utility poles to a range of built structures that have no precedent in the prior literature. Channel markers in active shipping lanes, decommissioned industrial structures on riverfronts, cell towers at varying distances from water. In one documented case from the upper Chesapeake Bay, a pair successfully nested on the roof of a building at a marina, using gravel ballast and rooftop mechanical equipment as anchoring points for a nest that would not have held in most traditional site descriptions. The marina was actively used throughout the nesting season. Boats were launching and returning, engines were running, dock workers were operating at close range beneath the building. The chick fledged. The pair returned the following year. Biologists tracking the substrate expansion have noted a feature of the pattern that adds a layer of complexity to the straightforward narrative of behavioral flexibility driving range expansion. The eagles most likely to occupy non-traditional sites are not uniformly distributed across age and experience classes. Younger, less experienced birds, specifically pairs in their first or second breeding season, are overrepresented in the non-traditional site records. This could reflect several things. It could mean that experienced pairs with established territories in traditional sites are not being displaced from those sites and are not the ones exploring alternatives. The non-traditional sites are being colonized by the overflow from a saturating population of breeders, specifically the young and the less competitive, who cannot secure the best traditional sites and are therefore selecting from what remains. In this reading, the non-traditional sites are the marginal habitat of a population at expansion capacity, occupied by the birds who lost the competition for traditional territory rather than the birds who pioneered a new ecological niche. The successful reproduction at these sites would then reflect the genuine habitat quality of formerly undervalued locations, rather than an extraordinary behavioral adaptation. This interpretation is not uniformly accepted. Several researchers working with marked individuals in the mid-Atlantic have documented experienced pairs. Birds that had previously occupied traditional forested riparian sites, voluntarily relocating to non-traditional sites after the original site was disrupted by tree loss, development, or pair dissolution. The relocation behavior suggests that at least some experienced birds are making active choices to occupy non-traditional sites rather than simply being pushed there by competitive exclusion. The distinction matters for predicting the future trajectory of the trend, because voluntary adoption of non-traditional sites by experienced birds implies a genuine shift in site assessment criteria rather than simply a population overflow into marginal habitat. The nest monitoring data from non-traditional sites has revealed another finding that has surprised researchers familiar with the prior literature on bald eagle disturbance responses. The productivity advantage of experienced pairs, which in traditional settings shows a strong and well-documented relationship between breeding experience and chick survival, appears to be compressed at non-traditional sites. Pairs in their first breeding season at non-traditional urban or industrial sites are producing fledglings at rates closer to those of experienced pairs than would be expected from the traditional site data. One proposed explanation involves the character of the disturbance itself. A young, inexperienced pair, nesting at a traditional site in a forested riparian setting, faces a disturbance environment that is variable and somewhat unpredictable, specifically episodic human intrusion of varying intensity from hikers, kayakers, and other recreational users whose timing and proximity are not constant. A young pair nesting at an industrial site faces a disturbance environment that is intense but highly predictable. The trucks run on a schedule. The workers arrive and depart at consistent times. The machinery operates within a consistent noise envelope. A bird habituated to constant, predictable industrial noise may experience the industrial setting as lower in genuine unpredictability than a natural setting subjected to sporadic but intense recreational disturbance, and may be able to maintain incubation consistency and chick brooding schedules more reliably as a result. The hypothesis is not confirmed. It is consistent with what the productivity data shows, and it reframes what we mean by disturbance in ways that deserve formal investigation. The management and regulatory implications of the bald eagle's behavioral expansion are significant and are being addressed unevenly across the jurisdictions affected. The bald eagle retains federal protection under the Bald and Golden Eagle Protection Act, regardless of its removal from the endangered species list. Disturbing a nest, taking an eagle, or destroying nest trees without a federal permit remains illegal. This protection creates a specific and sometimes practically difficult situation when eagles choose to nest in locations that their presence significantly complicates. A utility pole nest inside an active industrial facility creates maintenance and operational challenges for the facility and for the utility that owns the pole. A nest in a marina building creates liability and operational concerns for the marina. A nest on a construction crane at an active building site, which has been documented in multiple incidents across the mid-Atlantic, creates an immediate and concrete problem for a construction schedule that cannot legally be modified to remove the nest without federal authorization. In each of these cases, the regulatory framework was designed to protect eagles from humans, and not to manage the complications that arise when eagles actively seek out human infrastructure for nesting purposes. The framework does not fit the situation neatly. Power companies across the Mid-Atlantic and Midwest have developed, with varying degrees of enthusiasm, protocols for managing bald eagle nests on their infrastructure. Some utilities proactively install artificial nest platforms near active poles to provide alternative structures that the birds might prefer. Some install protective equipment on poles carrying active electrical lines, both to protect the birds from electrocution and to protect the utility from the regulatory and public relations consequences of causing eagle mortality. The approaches are largely ad hoc, driven by individual company responses to specific situations, rather than by a coordinated federal or state policy framework designed for the current scale of non-traditional nest site occupancy. The scale of what would be needed to develop such a framework is only now becoming apparent as the extent of the behavioral shift becomes clear. The winter concentration behavior that precedes and in some ways predicts the spring nesting expansion is another dimension of the eagle's current relationship with human-modified landscapes that has received less attention than the nesting records themselves. Bald eagles congregate in winter at sites with reliable open water and abundant fish or waterfowl, and these congregations have been moving progressively closer to human population centers over the past 2 decades. Dam tailwaters below hydroelectric facilities, which remain ice-free through even severe winters due to the thermal properties of reservoir-released water, are classic winter congregation points. But the winter records now regularly include water treatment facility outflows in suburban areas, heated discharge channels from industrial plants, open water maintained by marina bubblers in urban harbors, and retention pond systems in commercial developments that remain ice-free due to stormwater inflow temperatures. Eagles are learning, or have learned, that human infrastructure reliably produces the open water and concentrated fish resources that their winter survival depends on. The winter use of human-modified water bodies is not new, but its prevalence in the current records reflects both a larger population making more choices and a progressive behavioral shift toward comfort with human proximity at close range. The research agenda that the bald eagle's behavioral expansion demands has not been fully assembled. The basic observational documentation is being done primarily by state wildlife agencies with the assistance of large volunteer monitoring networks that have emerged as the species has become more accessible to non-specialist observers in non-traditional locations. What is not being done at sufficient scale is the mechanistic work, the telemetry studies that would track individual birds from hatching at non-traditional sites through their own nest site selection as adults, the behavioral observation work that would document disturbance response thresholds at non-traditional versus traditional sites, and the comparative productivity analysis that would determine whether the fledgling success rates at non-traditional sites are genuinely comparable to traditional sites after controlling for the relevant variables. These are tractable questions. They require commitment of research resources that the current funding environment for wildlife biology does not reliably provide to a species that has been officially recovered and is no longer generating the conservation crisis attention that drives grant funding. The bald eagle that is nesting on a utility pole in a Pennsylvania industrial complex, on a marina rooftop in Maryland, on a channel marker in a New Jersey estuary, or on the ledge of a building within sight of a major American city, is not the bird that the recovery literature describes. It is something that the recovery produced and that the recovery literature did not fully anticipate. A population that has been through a bottleneck as severe as the one the bald eagle experienced in the mid-20th century, and has expanded as dramatically as it has since carried within it the accumulated behavioral flexibility of the individuals who were bold enough, or tolerant enough, or adaptable enough to survive and reproduce in the conditions of the recovery period. That flexibility, expressed across a population now numbering in the hundreds of thousands, is producing outcomes that the original models of the species ecology did not have the data to predict, because the data came from a population under pressure, and the population is no longer under pressure in the same way. It is finding new trees, new poles, new rooftops and channel markers, and retention pond margins. It is discovering, one pair at a time, one season at a time, that the world it inhabits is larger and more usable than the template suggested. The biologists watching this happen are doing what biologists do, when the data departs from the prior model. They are going back to the beginning, reconsidering what they know, what they assumed, and what the difference between those two things reveals about a species that has, in the course of a single human lifetime, come back from the edge of oblivion and started rewriting its own ecological story in places it was never supposed to reach.